So the lesson is on exponential functions. So the most essential competencies are the following. Represent real-life situations using exponential functions. Represents an exponential function through its table of values, graph equation. Distinguishes between an exponential function, exponential equation, and exponential inequality, and solve problems involving exponential function. So in our first activity, the paper folding activity and the holding hands activity, I ask you to represent your findings through a table of values, a graph, and an equation. So same with the other activity. So the equation that we have for the first activity is an example of an exponential function, which is y equals 2 raised to x, or f of x equals 2 raised to x. And for the second activity, it's y equals 1/2 raised to x. So as you can see, we're able to represent exponential function through table of values, graph, and equation. So for now, let's have a definition of an exponential function. An exponential function is defined as f of x equals a raised to x, where a is greater than 0 and a is not equal to 1. Here, x is any real number. So exponential functions are different than any other types of function because the independent variable is in the exponent. So we have here 2 as our base as for our activity. So you have the given point or values of x corresponding value of y. So if you'll graph, you'll have here the graph of the function f of x equals 2 raised to x. So we have the following equation. So let's identify which are exponential function or not based from the given definition. So we have the first one. Is it an exponential function or not? Yes, it's an exponential function. How about the second one? Not. So the third one is also an exponential function, as well as the fourth one, the sixth, the seventh, and ninth are examples of exponential function. So again, we have the first one, the third one, the fourth one, 6, 7, and 9 are example of exponential function. The rest are not example of exponential function or non-example of exponential function. Okay. So let's proceed also with an exponential equation. What is an exponential equation? An exponential equation is an equation in which the variable is found in the exponent. So here you have the examples of exponential equation. So 4 raised to x minus 1 equals 16, 9 raised to x squared equals 3 raised to x plus 3, 125 x raised to x minus 1, 25 raised to x equals 25, x raised to x plus 3, 4 raised to x times 2 raised to x squared equals 16 squared are example of exponential equation. Next is an exponential inequality. So, an exponential inequality is simply an inequality in one variable having a variable in the exponent. So earlier we have exponential function. Now we have exponential equation and exponential inequality. I hope you get to know the difference of the three when it is an exponential function, an exponential equation, and an exponential inequality. So exponential function is one of the important functions in mathematics. It is used to solve problems on population growth, compounding interest, radioactive decay, and many more. So these are the representation of exponential function rather in real life. So for population growth, we have the population after n years is denoted as P sub n equals P times 1 plus R raised to n. And if it is decreasing at the end of the year, it should be P sub n, or the population after n years, equals P times 1 minus R raised to n. So for all problems that you are to give an exponential model for each problem, then solve. So, for example, a population growth, a town has a population of 40,000 that is increasing at the rate of 5% each year. You're asked to find the population of the town after 6 years. So here, again, we have the formula. The population in n years equals P times the quantity 1 plus R raised to n. So here, as you can see, all you have to do is to substitute the given information in the formula. So 40,000 is P. Our n is 6 years. So you have 6. So this is our exponential model. So the exponential model is the model or the equation that you will use to answer the problem. So R here is 5%. Change it to decimal. That's why it's 0.05 raised to n. So after you substituted everything in the formula, all you have to do is to solve the given. So using your calculator, simply input 40,000 times 1 plus 0.05 raised to 6. So you will get 53,600 53,604. So you have 53,604. Okay, so that's for the first problem. So let's proceed to the next one. So we have compound interest. So P is invested at an annual rate. R compounded n times a year. Then the amount in the account at the end of t years is given by, again, the amount is equal to the amount invested times 1 plus R, the rate, annual rate, over n, the times of a year, raised to nt. So the annual rate is expressed as a decimal. So the following list shows the typical number of times the amount is being compounded. So annually, n is 1, semi-annually, n is 2, quarterly, n is 4, weekly, or rather monthly, n is 12, weekly, n is 52, and daily, n is 365. So for example, you have the given problem. If you deposited 15,000 in account, paying 5% compounded semi-annually, how much would you have in your account in 5 years? So we're asked for the amount. We're asked for the amount in 5 years. So we're looking for A. So P is the amount that you deposited, the initial amount, so that's 15,000. The rate is 5%, so you have 0.05. And N is the times of the year. So it's semi-annually, that's why it's 2. So, substituting all the information in the problem, you'll get the amount of money after 5 years as 19,201 and 27 pesos. Okay, so that is for semi-annually. Next. So a man wants to build a house in 10 years and it estimates that he needs to have 6 million by that time. If he plans to invest 8% compounded quarterly, how much would he need to invest now in order to have the money he needs in 10 years time? So, checking the given question, you have the given problem. How much would he need to invest in order to have the money he needs in 10 years time? So as you can see here, we're looking for the amount that she needs to deposit for him to get 6 million. So the amount is 6 million. Again, we're looking for P. This is compounded quarterly, that's why it's 4. And then 8%, so you have 0.08. So solving, we have 6 million equals P times 1.02 raised to 4 times T as our exponential model. So substituting 10 years, you'll have the amount that the man needs to invest is 2,717,342 and 49 centavos. Okay. So we also have, if we have exponential growth, we also have exponential decay. So exponential growth increasing. On the other hand, if we have exponential decay, it is reduced by a consistent rate over a period of time. So reduce, so meaning it's decreasing. So the formula y equals a times y minus b raised to x. Here, y is our final amount remaining after the decay over a period of time. A is the original amount, b is the decay factor, and x is the time. So, Engineer Reyes bought the latest model of a car worth 1.2 million pesos. If the value of the car depreciates by 12% a year, how much will the car cost after 4 years? So using the given formula, again, all we have to do is simply substitute. So you have your exponential model. So after 4 years, 12%, that's why it's 0.12. So we have the cost of the car after 4 years as 719,634 and 43 pesos. So a brand new car that costs 1.1 million has depreciated the value at 825,000 after a year. Find the value of the car when it is 3 years old. So here we're looking for the rate. Okay, so as you can see, we have the depreciated value, so the depreciated value, the original cost of the car, and then we don't know the rate. So after a year, that's why it's 1. So having that one, we can look for B. So B substituting, we have 0.75 equals 1 minus B. So B is 25. So meaning the rate is 25%. So the question here is find the value of the car when it is 3 years old. So after getting the rate, substitute. So you will have your exponential model. Again, the model that you are to use to solve the problem. Then substitute 3 because it's after 3 years. So using your calculators, we have the cost of the car after 3 years as 464,062 pesos and 50 centavos. So for exponential decay, we also have some substances such as radium, uranium, and carbon-14 diminish or decay over a period of time. The characteristics common to this substance is of what we call a half-life. So half-life is the time required for a radioactive substance to decay half to its original mass. So it means that after one half-life, 50% of the original mass of the substance remains. So after 2 half-lives, only 25% of the original mass. So the half-life of a certain radioactive substance is 6 days at the beginning. 6 days. At the beginning, there were 8 grams. How many grams will be present after 12 days? So the original amount is 8 grams. So the half-life is 6 days. So representing this one as a table, so you have the number of days. So 0, you have the initial amount, 8 grams. So the half-life is every 6 days. So from 8, it becomes 4. So after 6 days, which is 12 days, we have 2 grams. That's why the amount left after 12 days is 2 grams. So, a measure of rate of decay is the half-life of an isotope. That is the time it takes for half of the population to decay. So it's given by the formulas for half-life model. So A equals A sub 0 raised to 1/2, rather times 1/2 raised to T over N, or A equals A sub 0 times 2 raised to negative T over N. So let's understand the notation of the problem. So A is the amount at time T. A sub 0 is your amount at T equals 0, and N is the half-life. Again, amount at time T is A sub 0, amount at time T equals 0. So the initial amount, and N is our half-life. Okay, so let's try to answer some example. So the half-life of a certain radioactive substance is every 5 years. So every 5 years is the half-life. If initially there are 60 grams, so we have the initial amount of the substance, how much will it remain after 20 years? So 20 years is our time. So using the two formulas, you can see, again, all you have to do is to substitute in the given formulas, this time for half-life. So you have the two exponential model. Okay. So using the first formula, here your base is 2, here your base is 1/2. So substituting, you'll get the half-life after 20 years of the substance is 3.75 grams. So you may use either of the two formulas. It will give you the same answer. So second example, the radioactive isotope gallium-67 used in diagnosing malignant tumor has a biological half-life of 46.5 hours. So if we start with 100 milligrams of isotope, how many milligrams will be left after 24 hours? So again, we started with 100 and then the half-life. So you have your exponential model, and then to find the answer, 24 hours, so simply substitute it with the given time. So either of the two formulas, you'll have 69.92 milligrams. So please take note of the unit of measurement. You have to indicate the unit of measurement. So let's go back. So we have the representation of exponential functions in real life through the different problems presented. Again, we have population growth or population decay, exponential growth or exponential decay. For exponential decay, we have half-life. So how do we solve problems involving exponential function? So first, all you have to do is read the problem carefully. Understand what is asked in the problem. Second, after reading, you identify what is asked in the problem. Next is to make an exponential model from the given in the problem. And then, after making an exponential model, all you have to do is simply substitute the given in the given formulas presented. After that, you solve the problem. So that's how we solve problems involving exponential model. So for this presentation, we're able to represent exponential functions to table of values, equation, and graph. We also identify the difference between an exponential function, exponential equation, and exponential inequality. And lastly, solve problems involving exponential function. So that's it for exponential function.